45 years ago, a small group of men got together and changed the lives of almost 5 billion people on Earth. Yet you've never heard of them. Each year, their invention saves thousands of lives. They brought down the price of food, increased the efficiency of transportation worldwide. Without them, we would not have the internet. Online banking would be impossible. The technology that makes your cell phones work wouldn't exist. Brad Parkinson, Dick Schwartz, Hugo Freuhoff, and Jim Spilker brought together a team of exceptional engineers and scientists to create a program called the Global Positioning System. You know it as GPS.
We struggled over names, but it came out of an Air Force program called 621B.
The program was known as 621B at the time, and in that process, he recruited me and I came on board with him and Colonel Parkinson, Dr. Parkinson, and that was sort of the formulation of the program office.
621B, which was, I think, originally designed to be a tactical solution for navigation in Vietnam. Southeast Asia didn't have much in the way of waypoints, and out of that, the whole concept of a global system grew.
And as I think about it now, I was groomed for this. All my life I was doing this. As a young man, I loved maps. I went to the Naval Academy, had 2 years of navigation, including celestial. Went to MIT, worked with Dr. Aper on inertial navigation. I had 3 years testing inertial navigation, and I had been on AC-130 gunships as part of an introductory team. I appreciated the need for precision in the Air Force. I had taught astrodynamics, the idea of where a satellite goes and why it goes there, why it moves that way at the Air Force Academy. So I had a background that seemed exquisitely tailored to this, but I wasn't certain what this program was going to do.
Bob Renard and Mel Birnbaum and myself had gone up to talk to the NRL guys, the Navy guys, Roger Easton and company, about 2 weeks before the Pentagon meeting, arm wrestling with them on negotiating on sort of what this new system should look like.
Discussion about, well, what about the ground segment? What about the satellite? And what about the user equipment? And what did we know before that will carry over? And what didn't we know that's different that we ought to really think about?
Code division multiple access. That means that all the satellites are broadcasting on an individual code, and they're all on the same frequency.
But the orbit is not a stationary orbit like some of the communication satellites, but orbits that are moving rapidly at a medium altitude. The fact that the satellites are operating at these velocities, it causes a perturbation to the signal, and that they all have a very substantial Doppler shift.
It's a true story of triumph over adversity.
Well, the clock was the big one, and with getting it the accuracy that was going to be needed in order to have the user equipment work and then to get the signal down from the satellites.
Now GPS equals the clock equals GPS.
The tricky part, we knew, was going to be the clock.
The biggest problem on the satellite was the clock, of course.
So we found a German clockmaker who had offices in Munich, Germany, and Costa Mesa, California. And he had a rubidium frequency standard. And we teamed him with our electronics people at Rockwell Aerodynamics.
I, right from the beginning, started working on rubidium vapor atomic oscillators, and I personally didn't invent anything, but I figured out how to get the inventor to do all the right things.
And they packaged it such it would survive in space.
Atomic clock, a small atomic clock, is just as much of as a world changer than GPS is, because the laboratory device that did timing were about the size of a big microwave. And Ernst Jechert in Munich worked for Rohde & Schwarz, and in the late 60s he took that large development item, which was like a 19-inch rack, foot high, and he made a 4-inch by 4-inch by 4-inch atomic oscillator. at the same specs.
They had to design a system on a shoestring budget using borrowed equipment.
We got these boosters out of the wheat fields of Kansas, old Atlas boosters that were retreads that didn't cost us very much. We built our own stage vehicle to boost us into from the low Earth orbit that Atlas puts you in to kick us around, and then we put the Apache kick motor on the satellite to circularize it. And with that combination, we were then able to do it at very low cost.
They literally took a F-104 400 cycle generator and put that in that helicopter because we needed 400 cycle power, and helicopters are 28 volts, sorry. So it had a special Dash 1 to be able to fly this thing. We had to train our Army pilots on how to set it, otherwise they would dump our 400 cycle and we'd lose our test equipment.
Before we launched, I used to have a meeting with them. We were all ready to go and that kind of stuff. And I'd say at the beginning of the meeting, this meeting is not about money, it is not about schedule, it's about, are you ready to launch? Because we're launching our reputation, we're launching the ability of this system to work. So if you got anything to say it now. You know, if it's launched, fine. If it's not, say it now and we'll take care of it. And that was a way to put the responsibility on them, and they felt it and they enjoyed it. But that was kind of a little seance almost that we had. Are we ready to go? It's us flying. Because once we kiss it goodbye, we're never going to see it again, you know, that kind of stuff. We're never going to touch it.
The command and control of the satellite, to put it in the right orbit and to maintain the health, was done at Sunnyvale. So I had the little detachment, 4 of us. We actually did all the procedures and everything.
When we launched the first GPS satellite, we had a problem acquiring the Earth.
We got it up in orbit, the launch was flawless, and we were moving it into its final position.
The booster put us in a big elliptical orbit. And our job was to get to the top of that orbit, and then we had a motor in the satellite that circularized the motor. So we had to know how to do that. We knew the orbital parameters, and in those days, the Air Force did the calculation of the orbits and that kind of stuff. But our guy, in those days, we equipped him with a handheld computer, which was the size of a briefcase, and he used to do the check of the orbits then, and we'd do any adjusting, and we were the ones who we deployed the wings on the satellites, and we had to acquire the Earth.
The clock was ticking, and the panels, we had to deploy the panels, we had to spin the satellite up and face the satellite kind of toward the sun, right, in order to get the sunlight on that. And it's inertial space, so no one could know exactly where the satellite was facing. So it was really a challenging thing.
About 8 months before we launched the first satellite, and this was another trick that we had learned from the NRO, is to do what we called hardware in the loop testing. So we got some old attitude control and acquisition sensors, and we cobbled together the hardware, and then we ran the software through that. And so we had a little laboratory where we had done that. And I don't think Brad was for that because, our budget was tight. He wanted us to do other stuff. I don't think I'm telling anything out of turn here, but I said, no, we got to keep that going. So we did. And so sure enough, when we launched the first GPS satellite, we had problems with acquisition. So that's always a critical time because you're on battery power until you acquire the Earth, and then you get stabilized. Then you can unfold the solar arrays and start getting some power. But if you don't acquire, you just lose it.
First acquisition on the first satellite, our guy who led the attitude control system, we went up to Sunnyvale, which was the first control center, the blue cube up there. And we launched the satellite, and we jump in the car and we race up to Sunnyvale.
Right, Dick came up. Dick Schwartz was the Rocco guy. He came up. We had more visibility, knew what to do with it.
And so we're deploying it, and he's on his console there, and I'm leaning right on his shoulder looking at it. and the satellite's oscillating and it gets smaller and smaller, and there's the Earth. And he turns to me and says, "Piece of cake, Dick."
And what it had was what they call a plume effect. The solar panels were low, and when the thrusters fired, the thrusters got over the solar panel. It was like a jet, and it oscillated the spacecraft, and the spacecraft started to tumble.
He turns around and oscillates right off the thing.
A lot of Rockwell guys, a lot of guys from the program office came up.
We were able then to patch, because we already had this laboratory up and going, we were able to patch some software things together, try it out in the laboratory, found it worked, you know, shipped it up to the Blue Cube in Sunnyvale, put it on, and voila, we acquire.
That was kind of a really scary moment.
But he says, "I will never say piece of cake again."
They overcame incredible engineering challenges, and all the while, no one wanted it.
Convincing the Air Force and convincing the funding people that it was going to be that big was a real challenge.
Since Brad was very busy running the program back out in Los Angeles and trying to get our act together on that, Steve Gilbert, who was his deputy, was all over the East Coast, not just marketing GPS, but explaining why it needed to be funded, why it needed to be part of not just the Air Force budget, but the OSD budget and the President's budget.
The operational Air Force didn't want it. There is a sundial made out of black granite in front of the train station in Los Angeles. And it has 3 little phrases on it that absolutely represented what we were. The first was the vision to see. We could see what this could become. And that was essential. But you also had to have the faith, that's the second phrase, the faith to believe that we could really pull it off. And lastly, courage to do, the third phrase. We had to throw ourselves 110% into this, and I had people that were doing even more than that.
The reason that it was a success was the program office, especially the Air Force, was very smart. Brad really, well, Brad's very smart, of course, but the thing is that he hired into his program office Air Force officers who were all very smart, and that really helps.
Remember back when it was easy to get lost and fold a map, gas up, go where the lines cross. Makes me laugh to think how times have changed.
In no way did we imagine what it's doing today.
Who'd have known the big dreams that we chase? Odds were stacked, but hey, we did okay. The beaten path was never